Hello, my friend. My name is Anton from Karneliuk.com, and we continue today our video series about pygnmi, the Python library we have created for you to help you to manage your devices with GNMI using Python. In previous videos, we have already covered quite extensively various basic calls such as capabilities, get, set, subscribe, so streaming telemetry both for the Nokia or on the examples of the Nokia SRS devices and Arista EOS. We have get quite a few requests from some of you in the GitHub or in their private mails or in the chat in their LinkedIn, how you can use certificates to encrypt the traffic towards their devices. And in this video, we will show you probably one of the easiest way to register, well, probably not the easiest, but the easiest in the lab, is how to use the self-signed certificates with pygnmi to make sure the connectivity channel between your GNMI host and your server running pygnmi is encrypted. So just to remind, you see our lab, we have the server running pygnmi, and we have some other devices, which is Nokia SRS based router and Arista EOS bias, right? However, based on the feedbacks that we have received from the colleagues, their pygnmi was already tested against Cisco SXR, and it was tested with a certificate actually, and the same for the Juniper. So effectively, this library is working for all possible vendors, and it doesn't bind to any particular YAN models. So long story short, how we deal with a self-signed certificate. I will show you the example of the Arista today because it is really easy, but the same would be working for the Nokia. The same would be working for the Nokia SR Linux, Cisco, Juniper, and all other operating systems. So let's jump to our device. So let's jump to our EOS. I will start sharing the VES code so that you could see the details. So we are on having opened this GNMI script that we have created previously. So just to show you py get or GNMI get, right? So we can connect to the device. So this is our router that we was dealing previously in the lab, and we are receiving the GNMI message. So let me do it probably bigger. So we are receiving the GNMI messages that contains all the information in the native Python dictionary about the device. So now we need to change the way how we are working. So we are using this now using the insecure channel. And for the secure channel, we need to provide the certificate, which we would use to authenticate our device against. If you have PKI, and for PKI-based solution, we'll have a separate video that would be working relatively easy. So you just need to have the certificate from your destination device, and that is it. For the self-signed, we need still to have the certificate, but as we do not have the proper PKI, we need to use some other activities. So first of all, let's jump to our Arista and let's generate the crypto key for the certificate. So crypto security PKI key generate RSA 4096. What would be our name? Let's say pygnmi self key. Okay, so we're generating the RSA key. It will take a few moments to generate depending how many performance our system is having at the moment. Could be quick, could be long. But anyway, so the key is generated. Now let's generate their certificate. So security PKI certificate, generate self-signed. Let's call it pygnmi self-certificate. The keys that we are using would be the one that we have just created, pygnmi self key, and generate RSA No, I don't need to have a key. Generate. Okay, so we are generating now our certificate. In the common subject name, we need to provide our host name. So EOS, this router is called EOS 425. Okay, so other stuff we could basically skip. We don't need to have that. We just need to have the name to be used. So certificate is being generated again. It's taking a few more minutes. Obviously, if you're building for the PKI, we should fill in properly all that stuff. But for now, we could skip all these parameters. So the certificate is being generated, and once it is generated, we would need to create the security profile. On other hosts, on the Cisco iOS XR, on the Nokia SRS device, it would be obviously the other way how you'll be generated the self-signed certificate. You could probably even reuse the one that are shipped with the device. So potentially would be fine. So, but if you can generate, it's better even to generate the self-signed certificate for the lab purposes. So let's check our show management SSL, so management security SSL certificate. So this would be our name of the certificate. So you see, we have the certificate. So we have common name. We have for the subject, and we have the things. So basically, we have now the certificate, which is valid one. So it's active. So we can progress with that further. Okay, so what we need to do now, we need to create their profile. So how we do it, configure. Terminal, and we are creating now the management profile that will, or SSL profile that will be binding both the key and the key together. So we do it using the in configuration mode, management security, SSL, management security, SSL profile, pygnmi profile, certificate, using the name of the certificate we have just created, key, the corresponding key, active, so it shows the profile we have created. So now we will check whether the profile is valid. So management security, SSL profile, pygnmi profile. You see profile is valid. So now I would apply this profile to the GNMI context, transport gRPC def, and I would apply SSL profile pygnmi. All right, so now if I take a look now, show management API GNMI, so you'd see that profile is applied. So if I would try now to get out back to my script and try to run the get how I was doing previously, I don't have yet the certificate. So we are getting the timeout error. We are not able to pull the information from the device. So we are receiving the pushback. So how we can deal now? Because the device requires the session to be protected. So we're going back to the device, and we're searching for this certificate. So we're going into the bash context within the Arista, and we're going into the folder persistent secure SSL, and then I'm searching here for the certificates, and the one that we have just created, pygnmi self-cert. So it gives us the content of the certificate that we need to copy. And in the folder with your GNMI, we have created an empty folder called certs. So new file, let's say device PEM, so that would be a certificate. And we are copying in there this content of this file from our device. So the next thing what we need to do, as we cannot do the validation, we do not have the neither PKI, we don't have the DNS. So what we need to make sure now it is working, in our this code, we'll create a new variable. So let's say it will be PC, means pass to certificate. We provide the pass to this certificate we have just created, cert device PEM. And then in our configuration context, when we build the channel down to the devices, we are saying that we have a parser cert, which is containing the value out of the PC. And as we do not have the possibility to do the proper validation, we are adding the key override. The override would make sure that we are using the custom string to match against the issue. So our host name and what we have within the certificate when we was looking previously is this one. So EOS 425, this is our issue, and this is what needs to be matched in the certificate against. And the same as with subject. So then we add here in the override the subject that we have used. Now that would make sure that we can connect to the device, so encrypt channel using the certificate. We are just overriding this field. So let's check. So now if we run our Python GNMI, you are seeing that now the connectivity is working. So it means the connectivity now is established with the SSL, and we have this message protected against if it is encrypted. So if it is intercepted, it still will be encrypted. So, and this gives you possibility and ideas how you could use the GNMI with the encrypted channel within your lab. Yes, compared to their normal HTTP-based protocols like REST API and so on, or it's not correct to say, probably the other Python libraries which we have like requests and others used for the HTTP REST API requests, we have possibility to skip certificate check by default. The gRPC-IO library, which we are using underneath within our pygnmi library, does not allow us to skip their certificate check. Probably it is bad, but it's created or it is done so with a purpose of the security. And obviously in the live network, you would like to have the security, you would like to have their channels encrypted. In the separate video, we'll show how to deploy their pygnmi when you have their proper PKI context. But for now, you see, you could create the self-cert certificate on your device, copy it to your host running pygnmi, and override some field just to make sure that the validations would be successful. Thank you very much for watching this video. I hope it answered a lot of questions that some of you was asking recently. And happy labbing with Python, GNMI, and pygnmi libraries. If you have any questions, feel free to ask us here in the comments on Write the Issue on the GitHub. Looking forward to hear your feedbacks. Take care and goodbye.